Hello. Hello. تسمعوني؟
Hello.
Hello. So basically, we will solve a problem. All right. Okay. So if you consider a low-pass filter composed of a resistor and a capacitor here, so the differential equation obeyed by the voltage here U, which is the output voltage across the capacitor, is the following: RC du over dt plus U is equal to U0, where U0 is, okay, the input voltage, the voltage of the power supply here. Right? And at time equals 0, when you switch on the switch, so the U here is 0. So this is the differential equation that is obeyed. So the questions are, okay, so one, show that this equation admits a unique solution. Okay. 2, find the analytical solution. And 3, okay, study the behavior of the solution with respect to round of error. Okay, and 4, okay, write a program that plots the solution U as function of t, using the Euler methods. The RK2A or RK2B and the RK4. This will not do it because this we already did it. Okay, so it's the same thing doing this than for any function. Okay, but if you want to show that this equation admits a unique solution, all right. So first, well, if you want to show that the equation admits a unique solution, you must study if it's a Lipschitz function per respect to its second variable. So basically, okay, what we did before is like to express dy of f of xy here. Okay, okay, our function is u, right?
Mm-hmm.
So the y is the u, right?
X is T.
This problem, when I gave it in one exam one day, nobody got it right because they get confused. Where is the y? Where it's, I mean, it's the same thing, but here you change the x is the t here, all right? So if I want to express it of this form, so I get du over dt. I must express it. This is that way. Du over dt is equal to 1 over rc u0 minus u. Okay, so this is of the form du over dt is f of, okay, ut. Here it doesn't depend on t even, right? The function f. So it depends just on u. But, okay,
Mm-hmm.
this is my function f here, right? So if you want to express any problem as the form that, okay, of this form, you just have to express, okay, the derivative as function of, okay, u and t. Okay, so here, okay, the variable y that we have is u, as I repeat, and the variable here x, okay, is t. So it's better to express it f of tu, right? But as I said, it doesn't depend on t, even this function f. And now, if you want to see if it admits a unique solution, it must be a Lipschitz function per respect to the second variable, yani per respect to u, right? Okay, so it must be a Lipschitz function per respect to u. Is it a Lipschitz function per respect to u? So this is what we must study here. Okay, that's okay. So is it a Lipschitz function per respect to u? Okay, basically what you must do is the following. F is f of t u2 minus f of t u1, where u1 and u2 are two values, given values of 2. Is it inferior or equal, okay, to some here, okay, quantity u2 minus u1, right? So, if you take here, you get that if I take f of t u2 minus f of t u1 here, okay, what I get is 1 over rc u1 minus u2, or u2 minus
Mm-hmm.
u1 is the same thing. Okay, so yeah, you have here, okay, this is your variable L here. So it's a Lipschitz function with respect to u here. And we have a unique solution. Now, the analytical solution of this thing is quite easy here. Okay, so first of all, you need to, okay, solve the homogeneous equation, right? So you solve the homogeneous equation, and then you use or the method of variation of constants, or you add a particular solution, which a particular solution here is a constant. Okay, so you can do either way, right? So Uh, so let's do the analytical solution here. So on the analytical solution here of this, okay, du over dt 1 over rc 0 minus u. First, we consider the homogeneous equation. The homogeneous equation, du over dt plus 1 over rcu is equal to 0. Okay, this is the homogeneous equation. Okay, and then you can, okay, apply here. Okay, this is quite easy. So it's du over dt is 1 over rcu, yani minus here, right? So when du over u, okay, this is called the separable equation, minus 1 over rc dt. When you integrate this now, you get that log of u is minus 1 of rc t plus some constant, and then when you take the exponential, you get u is equal minus 1 over rc t. Okay, exponential of the constant. Exponential of the constant is another constant, so we call it k. Okay, exponential minus 1 over rct. Okay, now هنعمل food. Okay, what you can do is that use the method of variation of constant. Okay, so the method of variation of constant you use here for this k, instead of using, now you will replace, so this is the solution of the homogeneous equation. If you want to get the solution of this equation, okay, you have to use here, okay, u is equal k of t, so this constants you make it depend on t. This is called the method of variation of the constant. Okay, and then you put it again in this equation. So what you get is k prime of t multiplied by, okay, exponential minus t over rc. Now plus, now if I derive this, okay, now plus k of t multiplied by 1 over rc exponential minus t over rc, okay, is equal to, okay, 1 over rc u 0. All right. So, 1 over rc is, okay, so what you get now, you will get an expression now for k prime. So you get this one.
Hey, that's another differential equation.
Yeah, you will get another differential equation here. So, I mean, here is the method of variation of constant is a little bit more complicated solution, but wait to see if, so what we get is k prime plus k over 1 over RC is equal to 1 over RC 0 exponential T over RC, and yeah, so here it's a little bit more complicated, but I mean, to solve this, I mean, what you will get is that k prime, you will get the same differential equation. You will get also, okay, that k prime is a constant plus, okay, you will get that k prime is that k is the exponential of t over rc, okay, plus some constant. Okay, but it's a little bit more complicated here to do that. All right, so um, what you could have used instead of using this is use a particular solution. So that the solution u is the, I mean, you can get the result with this variation of constant, but in this case, okay, in other cases, it may lead to a simple solution, but here,
Mm.
okay, it's more complicated. But you can, I mean, you will get the same thing. You will get a plus exponential, and when you include this here, you will get the solution. I mean, it's doable, but it's a little bit more complicated. But you could have used that it's the homogeneous equation plus a particular solution. Like here, a particular solution, UP is a constant, okay? So, um, so if I take here, particular solution here is a constant. So dup over dt, okay, the constant is 0, 1 over RC u0 minus, okay, u. So I get here that the particular solution, okay, so 1 over RC, okay, if I take UP as a constant here, okay, u0 minus u as um, minus UP. So UP is equal to 1 over RC, right? 1 over RC u0 minus, so this is 0, so P is equal 1 over RC u0, right? So my general solution is 1 over RC multiplied by u0, okay? Sorry, what I did here. It's minus here, it is UP equals u0 here. Okay. So, sorry for that. So okay, because what I did is replacing UP here in this equation, and when you replace, so here you get 0, so you get 1 over RC u0 minus UP is equal to 0, so UP equals u0. Okay, and so you get that u is equal to u0
U0 plus K
plus k, okay,
exponential
exponential
minus T over RC.
t. And then now if you take u of t equals 0 is equal to 0, so you get that k is equal minus u0, and then you get that uh, you get that u is equal to u0 1 minus exponential minus t over c. So this is what we know
Okay.
for the charge of the capacitor here. It's this one. Now, for the method of variation of the constant, usually it works, but here, okay, it also works. But the thing is that here you have to also solve this one, right? So what you do is that you solve this one, you redo a here a you resolve the homogeneous equation for this one using the exponential here, and what you will get an expression for k, all right, multiplied by some constants, and then you apply in fact the initial solution. Okay, so here I mean it's even useless. I mean you get the same kind of type of equation for the k, okay, for the method of variation of constants. So it's better to use here a particular solution. But in other cases, this might work. Okay, all right. So now this is for the analytical solution. Now, if we want to study the behavior of the solution with respect to initial conditions, so basically you take a u here, okay. Instead of u t equals 0, you take u of t is equal to 0, you take u of t equals 0 is equal to some epsilon here, okay. So where epsilon is some error, round of error here, okay. So if instead of 0 I take okay epsilon, so I will express here, so I get u of t equals 0 is equal to u0 plus k is equal to epsilon, and k is equal to epsilon minus u0. So my solution will become u is equal to, okay, instead of this, okay, u0 plus epsilon minus u0 exponential minus t over rc. Now if I express it as before, so it's u0 1 minus exponential minus t over rc plus epsilon exponential minus t over rc. So you can see that this scheme is stable with respect to round of error, because the error doesn't increase exponentially with t. Okay, basically it decreases with t. So
Mhm.
if we had here a plus, then we will have a problem. But here in this case, we do not have a problem because it is okay decreasing with t. So this is quite stable, and this will work with any of the methods. So the Euler method will remain stable, the RK2A will remain stable, the RK4 will remain stable, they will all remain stable, okay, and we will not have a problem here of divergence with respect to the solution. So you can try that, okay.
Okay.
Yeah. Uh, Now, as a problem that I want you to solve at home, okay, I'll give you a problem. So problem 2 here. Okay, so consider equation. Okay, dy over dx is equal to 1 plus y squared. Okay, x y of 0 is equal to 1. Okay, and the same questions that before. So basically, these are the type of questions. يعني أول شيء we must like so verify if the equation admits a unique solution. Okay, B, find the analytical solution. And C, study the behavior with respect to round-off error. This is are the typical question that you will get, okay, in the exam. And I can ask you to write a program of one of the methods, okay. So we study. Okay, you will see the exam. I will send you the sessions soon, and you will see that they are all typical. So the same type of question that you can encounter. So try to solve this at home, and maybe if we have time, we will correct it. I will send you the correction next time. So I'll let you copy this now, and we'll start a new chapter. We'll start a new chapter maybe after the break. How many time we have still? How much time do we have still?
بعد في 13 minutes.
10 minutes, yeah. It's okay. Let's stop it now and start a new chapter after 5 minutes, right?
Okay.
Yeah. Like this in the videos, you will have the videos corresponding to each of the chapters. Right. Okay, so now we will start the last chapter.
دكتور هيكون عندنا كل 6 chapters للفحص؟
شوف الو بتسمعوني؟
نعم دكتور، بس دكتور عندنا سؤال. عندنا كل التشابترز رح يكونوا للفاينلز 6
عم
تشابترز،
بيقطي شوي.
ومو
دكتور عندنا كل
عندنا
الشابترز
كل الستة
للفاينل.
تشابترز للفحص.
ايه
ما معقول يتخفف شوي، كل الأساتذة خففوا لنا.
كلهم
خبركم
خلصوا
بدي
لنا
اشوف
يعني.
مع دكتور حلبي. هلا هن 7 شابترز.
دكتور توفيق،
ايه
نحن بنحكي.
نحن
هو حكينا هلا انا وياه نتفق نشوف شو بدنا نشيل لانه بدنا نوحد الفحص. اوكي
إنه الصراحة قرب الفحص وعنا كتير، إنه كل المواد خففوا لنا بس لنشوف من هلا إذا بنلحق تندرس يعني، ماشي غير.
6
عن جد
تشابترز
صاروا
كمان
كتير
كتير كتار.
دكتور.
هلا بحكي معه برد عليك نص يعني.
دكتور عم بيعلق الصوت ما عم نسمعه.
يعني
دكتور في حال عم تحكي فد؟
لا لا
رد عليك.
الدكتور كتير عم
بس عم
بقطش.
بيقطع شوي ما بعرف
ايه
اذا
ما كنا عم نسمع
الكونكشن
شو كنت عم
تبعيتها عم
تقول.
بيقطش. Okay, so this is the last chapter. Okay, the resolution of four chapters or 5 chapters, 4 chapters, maybe 4.5. Okay.
مهم.
All right. So basically,
مش مبين
this
السكرين.
chapter is about the resolution, okay, of linear system of equation, which are encountered often in physics. You have to solve linear system of equation for a given problem. So a linear system of equation, when you have n variables, okay, then you have n equation. So a
دكتور مش مبين السكرين.
Alright.
منك عامل سكرين شير.
Yeah, right. So you have n variables here, x1 till xn, and then you have okay n equation x3 plus etc. a1n xn is equal to bn to b1. Okay. an1 x1 plus an2 x2 plus an3 x3 plus ann xn is equal to bn. Right. So this system of equations, okay, you can express it, okay, in a matrix form. So ax equals b, okay, with your matrix A being a11 till a1n, an1 till ann. The vector b here is the vector b1 till bn. Okay, so basically the object of this chapter is to determine the variable x, right? The vector x here, it is the unknown of the problem, knowing the elements of the matrix A and B. Right? Now, as a starting case, we'll consider a simple case, which is the triangular matrix case. Triangular matrix, okay, case. So for triangular matrix, where you have A here is a triangular matrix, okay? Consider an upper, suppose that A is an upper triangular matrix. For a lower triangular matrix, it works the same, okay? So in this case, A is A1, okay, till A1. And here I have A and N, and here I have zeros here, right? Everywhere zeros. Lower than the diagonal, I have zeros, okay? By x1 till xn is equal, okay, b1 till bn. So solving this system, okay, doesn't pose any difficulties here, because you can start by the lowers, the last line here, and go up. Okay, so here you have. So if I start by the last line, of course, for a lower triangular matrix, I would start from the first line. Okay? So I start by the last equation. So a n n xn is equal to
bn.
Then xn is equal to, okay, bn over a n n. And now, once I get the xn, I go and I evaluate the xn minus 1. So this is the xn minus 1 here. And here I have a n 1 n. And here I have a n1 and n minus 1 and minus 1. Okay, so I have that a n minus 1 n minus 1. Okay, x n minus 1 plus a n minus 1 and xn is equal to bn minus 1, right? So now I know the xn, I can evaluate the xn minus 1. So I get that xn minus 1 is equal to bn minus 1 minus a n minus 1 n xn, right? So solving a triangular system of equation. Now, if I want to put this into an equation, so general formula would be xi is equal to bi minus, okay, now of course for the xn minus 2, then you use here, okay, it's for xn minus 2, so it's bn minus 2 minus, okay, a n minus 2 n minus 1 xn minus 1 a n minus a n minus 2 n xn, etc. Right? So the general formula here is xi is equal to bi minus the sum of aij xj. Okay? But the thing is that over aii here. So here it's divided by, this here is divided by, okay, a n minus 1 n minus 1. And here this is divided by a n minus 2, okay, and minus 2. Right. So the general formula is xi is equal to bi, the sum of aij xj divided by, okay, aii. But here the sum, okay, the sums goes from what to what, right? It goes from j equals I plus 1, okay, till n. Right? Hello?
Yes.
Okay.
Okay.
لأنه n minus 2, right? So you get n minus 1 n, n minus 1, you get n extra. So you go from, okay, I plus 1 here till n. So writing a program to solve, if you want to write it in MATLAB, okay, this program, okay, for example, let's take a is equal 1 2 3, okay, 0 4 5 0 0 6 and b is equal 1 2 3. Okay, so if you want to write this in MATLAB, so you write the matrix A 1 2 3 0 4 5 0 0 6, and okay, 1 2 3, right? And now your n is length of b. Now the code that is length of b or length of a, it's the, okay, but I mean for a you need to use the command, okay, size, but here, okay, which will return you n and n, the n by m, and here 3 by 3.
Mm-hmm.
Oh, let's use the length of b, so here it will be 3, right? So because the next code here that I will use is that it will be general for any matrix A and B. So that's why I don't choose 3 here. So, and then the x is, you can initialize the x by zeros and 1, it's a vector, right? And now you start by, all right, so you start by, let's just like erase this here. Okay, you start by calculating x of n here. The last, okay, is equal to bn over ann, right? So this is here. And then here, I make a for loop, okay, for, okay, I equals, now the I, this is the last, okay, so we have the matrix n and we will need to go up in the I, okay, determine the, we determine the xn, we need to determine the xn minus 1, etc. So one way of doing it is to say for I equals n minus 1, 1, okay.
Mm-hmm.
This is, you know, you're going from n minus 1 till 1, right? And then you write the formula here, okay? So now we need to apply this here. So it's this minus this sum. In order to calculate this sum, I will use here another for loop. So here I will use, for example, s equals 0 to initialize this quantity, this sum, right? And then I will use for j, equals I plus 1 till n here, all right? And S is equal, I want to calculate this sum now, Aij xj, okay? S plus Aij, okay, x, MATLAB you have here, xj, then you end it. Right, and then at the end you calculate xi is equal to bi minus s divided by aii. So, and then good. Okay, so that's how you would calculate the solution here, xi for any for a triangular matrix, an upper triangular matrix. Now, if it's a lower triangular matrix, you don't have this problem. Then you will get here. It's the same expression here, of course, but the sum doesn't go anymore from I plus 1 till n. It goes from what to what?
On J is 3.
If you have a
Wow.
lower triangular matrix, instead
Mm.
of this, you start by the x2 here, okay? There. So J's goes from 1 till I, right? 1 till I minus 1. Hmm?
1
يعني
till I minus 1.
ايه لانه you start يعني ال x1 عندك اياها if it's a lower triangular يعني ال a1 هي C1 يعني a11 x1 equals b1 and you determine تعمل هيدا ك initial step بعدين the I will go, you will determine the I from 2
2.
till n, right?
Okay.
Well, 2 you will use the 1, so it will goes from, okay, I will goes from 1 till I minus 1, okay?
Okay.
يعني انه for x equals 2 then you will use the x just like it goes from 1 to 1 يعني just 1, okay? لل x3 you will use the x2 and the x3, the x1 and the x2 يعني it will go for I equals from 1 till 3 minus 1 يعني till 2 stuff. Okay, all right? Okay, so for lower triangular matrix here, instead of doing this here, you will go from I equals 1 till I minus 1. Okay, and you will not go here, you will not go from the I n minus 1, you will not start by the lowest value here, the value n minus 1, but you will start from the value 2 till n. This is the difference. Okay, هون عم نطلع هيك. Okay, so هون عنا هيدي الفاليو نطلع هيك، هيديك بكون عنا this one وننزل هيك. Okay. Okay, so this is the only difference in the code if it's a lower triangular matrix instead of an upper triangular matrix. Okay, now this is the general formula. Okay, so you can try to put this in MATLAB code and see if it works and what it gives. And after you verify A by X, you should get B. It gives you, this will give you something. You make A by X, it should give you. All right, so this is for the triangular system of equation. Now, we will discuss the Gaussian elimination. So the idea behind the Gaussian elimination. So if you have system A11, A1n, AN1, ANN, okay, multiply by x1, xn is equal to b1, bn. The idea is convert the system into a triangular system of an upper triangular, okay, system of equation. Yani, this matrix will become triangular. And how we do that? We do that by subtracting lines, okay? So we keep this line, we start from the second line and we subtract, okay, lines. So we subtract this first line from all these lines by ponderated coefficient. We get zeros here, and we continue like this till we get the triangular system of equation. Okay, and then solve the triangular system of equation. We know to solve the triangular system of equation. Okay. So this is a two-step, okay? So we have these two steps. First, we have to convert the system into a triangular system and then solve the triangular system of equation. All right. So how we do this to convert the system, okay, into, okay, so suppose that we have, okay, so what we will do is that, okay, let's augment the matrix. I don't know if you, okay, if you augment the matrix, it will facilitate, in fact, the, okay, if you put, because the operation that you will do the subtraction and they will apply to B also, right? So when you subtract lines and things like this will apply to the vector B also. You will do the same operation, and so when you change the system of equation by subtracting lines, etc., you change the same way the vector B. So augmenting the matrix is putting the vector B here. Right? So A and one, so A2, 1, okay, A2n, B2, AN1, ANN, yeah. So as a first step here, the first step, we want to remove the zeros here. We want to put zeros here, right? So we will have, this line is unchanged, and here we'll have zeros on all these lines. So what we'll do is that we will subtract, so the line 2, okay, what we'll do is that we'll subtract the line 2, we'll convert it into line 2 minus, okay, if I take A21 over A11, right, the line 1, I will have a 0 on the line 2, right? And line 3, etc., line 3 minus, okay, A31 over A11, line 4, etc., line n, okay, ln minus an1 over a11, Okay.
Ln minus 1. Ln أو Ln minus 1.
Sorry, it's L1. Here I'm subtracting. I'm subtracting the L.
From the first. Okay.
Yeah, I'm just
From the first line.
subtracting line 1. All right. Okay, so and the second step, what you will do now at the second step here, right, what you will get is, so after the first step, your matrix looks like this. So it looks like A11, A1n. Here you have zeros everywhere, right? So you get here A21, A22, sorry, right? A2n, A2, AN2, ANN. Okay. Now, just for convenience here, okay, we'll not use it in the program, but just like that you understand here, I will put it here. So this is, I will put an index 1 because this A22 is not the same than this A22 here, right? Because it has been subtracted here. Okay, so this is after the first step. Yeah, this means that it's after the first step. Okay, these I got new values here for the 82 except. Okay, now, okay, at the second step, okay, the second step, what I will do is that I will subtract. So these two, I keep them because I want a triangular matrix, right? Okay, and here it's the same thing. So if my matrix is augmented here, okay, so the B vector has been subtracted. Come in. Okay, so this is new values here for the B. So same thing here. Okay, so at the second step here, right? I want to subtract now, okay, from all these lines, from the line 2 here. So this, I keep the line 2. So now L3 will become what? Okay, so here I have A32, etc. Okay, so the line 3 here will be converted into L3
L3 minus.
Okay, so this is here A32, right? A32 over A22, okay, of L2, L4 minus A42 over A22 of L2. And okay, N minus, okay, A5, AN2 over A22. Okay. So after the second step, what I will get is A11, okay, here B1. Okay. So these they remain unchanged, but I will put an index 2 here. But these are remain unchanged, and for the second line also, it's the same than before, right? So let's still put an index 2 here. But these are unchanged because I didn't touch them. Now, what changed here is that now here I got zeros everywhere here on the second column now here, and I get A33 of 2, etc., B3 of 2, etc. And here I get AN3 of 2, ANN of 2, BN. So now I will repeat the same procedure. So this is the Gauss geometer till my matrix is diagonal. Now I will subtract, okay, the third line now from the rest, right? So, and now what we need is to find the general formula so we can apply this in a program, right? So if you look at here, okay, so basically at the first step, right? So you have that you're subtracting, okay, from you start by the line 2 till n. For the second step, okay, you start from the line 3 till n, etc. Okay, so at the step k, okay, you start from the line, okay, k plus 1 till n. Okay, so this is the first indication here. And then you subtract, okay, if I look at the equation here, okay, what do I subtract? Okay, so I subtract here, okay, the line. So if I have a line I, so I have the general expression is the line Li, okay, so at step k, okay, the line Li, okay, is the line Li at step k plus minus 1, okay, the previous line. Okay, like I said, we'll not use these indexes here for in the programming, but this is just like that you understand, okay, what we are doing. Minus, okay, we are subtracting the line. So at the first step, we're subtracting the line L1. At the second step, we're subtracting the line L2 and etc. So we are subtracting a coefficient multiplied by the line, okay, k. مظبوط? Right? What is this coefficient here that we are subtracting here? So if for the line L2, okay, at the first step, okay, we're subtracting A21, A31, for the line L3,
AIK,
A1, etc. So it's
AIK,
K, okay. Then the first step we subtract, okay. Here, second step, it's A32, etc. Okay, you can see here. So it's AIK, okay, over,
AKK.
okay, AKK, right. Okay, so this is what we get. Now, if we want to express it as matrix elements, okay, I can express now for the line I can put an index j for the matrix element. In MATLAB, I can't subtract lines of the matrix directly. Okay, we can do that. Okay, but if we want to express it as matrix element, I have to use the index j here for the elements of the line. All right, so this is the same thing as saying that Aij is, okay, this is here the line k command at step k minus 1. Okay, so I don't need to put it here. Okay, so Aij, okay, it's an element of this line Li is equal to Aij. Okay, this is at step, right, k minus 1, k minus 1 minus Aik over Akk, okay, AKJ here, look, the line K. That's step. Okay. So this is the same thing than this, all right? This is here, you're considering all the matrix elements, right? And now, so this is, so at step K, the index I will go from what till what? It will go from K plus 1 till N, right? Hello? And I'm smiling.
Yeah.
Okay, so at step K, at the first step, I went the index I here, okay, this line here that I modified it from 2 till N. هيدي خليتها. At the second step, okay, خليت this line, the second line, وراحت من so so the index I goes from K plus 1 till N. Okay, I can write it. Let's write it like this. Okay, it goes from K plus 1 till N. Okay, as for the index J, okay, for the index J, it goes command for K plus 1 till N. Okay. So it's the same thing. Okay. And this apply command vector B. So if you want to change the vector B, or you can use this same formula. If you can augment your matrix in your program and you add the column here, okay, and use this same formula to تغير B, okay. Or you can, okay, command like B, it's the same thing. BI will be BI minus AIK over AKK, okay, because you're doing the same operation on B, okay, and BJ. Sorry, here it's AIK over BK.